Kong is a city with high building density. Buildings consume about 90% of Hong Kong's total electricity consumption and contribute around 60% of carbon emission. You can imagine how much energy-saving potential there is. In view of this, the government has taken lead to promote and implement retro-commissioning, which is a systematic and cost-effective energy management measure in recent years. RCX can help to identify energy-saving potential and improve the performance of the building services installation inside the building, which is due to the deviation between design and actual operation, change of usage, behavioral changes of occupants, etc. This video will illustrate RCX measurement procedures for HVAC system, chiller plant, and provide examples. This video will cover 4 aspects, including 1. Importance of measurement. 2. Measurement items for chiller plant. 3. Measurement procedures. And 4. Identification of potential energy-saving opportunities. Measurement plays a vital role in retro-commissioning. 3 key processes are involved, including 1. Collecting trend log data to understand the operation of central building services installation. Checking the sensors and control of the central control monitoring system to see if replacement of defective parts is required before measurement. 2. Analyzing trend log data. And 3. Identifying potential energy-saving opportunities. Before formulating the measurement plan, it is necessary to carry out on-site inspection and preliminary checking of the HVAC system. Permission should be obtained from the person responsible for the premises, and they should be informed of the impact of measurement work. Also, the measurement plan must cover all required measurement items, relevant equipment and measurement areas. Next, a comprehensive measurement plan should be formulated to ensure measurement can be conducted smoothly. The measurement plan should cover system and equipment to be measured, location and measurement items, etc. Once the plan is formulated, it will be submitted to the responsible person for approval, so relevant data can be obtained for subsequent analysis. With regard to air-cooled chillers, 3 parameters should be measured, including 1. Power consumption of the air-cooled chiller and chilled water pump. 2. Chilled water flow. And 3. Chilled water supply and return temperatures to calculate the temperature difference. There are also 3 parameters for measurement works of water-cooled chillers, including 1. Power consumption of the water-cooled chiller, chilled water pump, condenser water pump and cooling tower. 2. Chilled water flow. And 3. Supply and return temperatures of the chilled water and condensing water to calculate the temperature difference. Using the above data, the coefficient of performance cooling of the chilled plant can be calculated to provide one of the indicators for assessing the efficiency of the HVAC system. Measuring chiller plant consumption helps to check and adjust the operation schedule of the chilled water plant and the chilled water supply temperature to review the building's actual cooling load requirement, whereas measuring the chilled water and condensing water supply and return temperatures helps to check the temperature difference between them. If the temperature difference is too small, it indicates that the heat exchange efficiency of the chilled water and condenser water is low, resulting in reduced overall operation efficiency of the chilled water plant. Therefore, by precisely controlling the speed of the chilled water pump, condenser water pump and cooling tower fan, the overall efficiency can be improved. The accuracy of the data is very important, as it has a direct impact on the subsequent data analysis and identification of energy-saving opportunities. Therefore, the central control and monitoring system log sheet should be checked to see if there are any abnormal data and to understand the current status of operation, including the operation schedule of the chilled water plant, whether the chiller is switched on or off, speed of the chilled water pump and condenser water pump, speed of the cooling tower, the status of the bypass valve, etc. 2 types of measuring instruments are commonly used for chillers. 1. Water flow meter and 2. Power logger. The water flow meter is used to measure water pressure as well as record the differential pressure, flow and temperature of the chilled water system. Power loggers are portable power quality analyzers that measure single-phase and 3-phase circuits with high precision, thus providing full power quality analysis. Meanwhile, recording intervals can be adjusted according to the technical guidelines on retro-commissioning established by the Electrical and Mechanical Services Department or the client's needs. Based on individual circumstances, different types of sensors and recorders can be used. Before conducting the measurement works on site, the RCX team shall be aware of the following items. RCX team will conduct measurement once they have obtained the responsible person's approval for the site measurement plan, the IoT equipment measurement plan, as well as valid calibration certificates for measuring instruments. Before conducting electrical measurement, competent personnel shall be appointed, such as registered electric worker of the appropriate grade, registered professional engineer of the electrical or building services disciplines, or registered safety officer, to assess the electrical safety of carrying out live work, and to recommend appropriate control measures. Information such as the completed electrical safety assessment form and work permits should be submitted. Each electrical measurement should be carried out by a registered electric worker, and a completed work completion certificate WR1 should be submitted afterwards. The RCX team will then meet with the responsible person for the premises and brief them on the overall measurement work to ensure they have a clear understanding of the workflow. Then the RCX team will locate the chilled water plant that needs to be measured according to the approved measurement plan. The RCX team will set up the data loggers based on the location in the measurement plan approved by the client and carry out subsequent measurement. Once setup is complete, the sensors will be installed through the test points and the data readings of the following parameters will be logged and recorded, such as chilled water flow rate, supply and return temperature, and differential pressure, and also water flow rate of decoupler or secondary circuit if applicable, and the power consumption of chillers. For measurement of chillers' power consumption, the RCX team and the registered electric worker should firstly locate the motor control center of the chiller plant. Upon carrying out measurement without electricity suspension, the registered electric worker must take all necessary safety precautions, such as wearing insulating gloves. Next, the registered electric worker will install a current transformer and data logger in the motor control center. Upon logger installation, the back panel of the motor control center should be reinstated, and a warning label should be attached to a visible position on the panel to remind other personnel not to interfere with the measurement. A photo record should be taken at the end of measurement works. During the measurement process, the RCX team can work with operators on site to better understand the limitations and characteristics of the site equipment, thus providing the client with tailor-made energy-saving opportunities. Not only does the energy-saving opportunities improve energy efficiency, but it also strikes a balance between cost-effectiveness and on-site constraint. While carrying out measurement, the measurement team can identify potential energy-saving opportunities through the issues identified during measurement. Common examples of potential energy savings opportunities: optimization of chilled water plant operation schedule. Based on the actual usage of the building and seasonal changes, the operation hours of the chilled water plant can be reduced to avoid unnecessary energy consumption. Optimization of cooling tower approach temperature. Based on the size of the cooling tower, operation of the fan in the cooling tower can be optimized to keep the approach temperature between 2 degrees Celsius and 8 degrees Celsius. The optimum approach temperature is close to the design approach temperature specified in the manufacturer's instructions. Meanwhile, operation of the fan above each unit can be adjusted to achieve this goal. In particular, when the wet bulb temperature is lower, the efficiency of the chiller can be improved. Applying variable speed drive for chilled water pump speed control. If the chilled water pump is fixed speed and the chilled water supply and return temperature difference is small, it means excessive chilled water is supplying the building, which is at low load condition. With the addition of VSD, together with the central control and monitoring system, the chilled water pump can be modulated to supply chilled water, fulfilling the actual cooling needs of the building, so as to reduce energy consumption. If a building is not equipped with a central control and monitoring system, the VSD and chilled water pump speed can be adjusted manually according to seasonal demand. Optimization of water supply temperature set point of chiller. The default temperature of the chiller can be adjusted to improve system efficiency. Throughout these potential energy-saving opportunities, unnecessary energy consumption can be reduced based on the building's mode of operation to improve system efficiency. After the measurement team has obtained the relevant data, specific recommendations can be provided to the responsible person of the premises to help them improve system efficiency in order to ensure equipment is operated in optimal conditions. Power consumption can be reduced, saving energy as well as operating cost. In conclusion, retro-commissioning brings a number of benefits, and we hope more buildings can improve energy efficiency through RCX. Energy consumption and carbon emissions can be reduced significantly, while goals of sustainable development and carbon neutrality can be fulfilled, making Hong Kong a more livable city.